Okay, so permutations. A few things about permutations before I start talking about it. Arrangement and permutations of the definition. You are lucky because one of the problems that we talked about yesterday or today already has permutation. Okay? It's talking about order, how many things you can put in an order, and the one that we did with the 80 and the 5040 with the numbers, that was a sample of permutation. But I'm going to explain it a little better today because this is completely what the lesson is about.
I have a question.
Sure.
Okay, so for track we get out at
You can leave right after
2:15. Okay. Because the 8th period starts at 2:14.
That's fine.
So it's
Fine. Yep.
yeah.
Right at
Mr. Brian's gonna make you stay for that one.
You can go. All right, arrangement, order, possibility of people, letters and numbers. A lot of times today we're going to talk about letters and numbers. Sometimes it'll be people. Permutations is arrangement in which order is important. So once you get this written down, let me show you some examples of this. This is fitting because I'm going to use track as a help. Use track, yeah, because track is like a lot of permutation. It has to do with track. And track pretty much is permutation. I'll show you in a second.
it is.
Yeah. Okay, so let's say these four right here are running a race for me. These four, this person. These four are running a race.
Hold up. Oh.
In this race, stop talking. In this race, how many options are there for first place?
7.
Four. Four people. You're just running this group of four is running a race. It doesn't matter. You four are running a race. It doesn't matter. Okay, you four are running a race. There's four possibilities for first place. All four of these people can possibly get first. Let's say Zaylee wins.
That's impossible.
Okay? Let's say she wins. Now, how many possibilities are there for second place? 3 places. Landon wins second place. That gives me 2 left. 50-50. Just listen. How many possibilities do I have for second place? 2 and 1. So 4 for first place, 3 for second place, 2 for third place, 1 for fourth place. 4 times 3 is 12. 12 times 2 is 24. There's 24 different ways I can line these 4 people up. Just 4 of them. That's crazy, isn't it? Okay. Well, let's think about a 5th person in now. Now, Isabella's running. Now, how many possibilities are there for first place? 5. Second place, there's 4. 3, 2, 1. 5 times 4. 20 times 3 is 60. Times 2 is 120. So just between these 5 people, there's 120 ways that I can line them up. That's crazy. Okay, so now let's think about it. Let's say I'm going to add a 6th person in. So I have 6 people. Now listen. Let's say in this race, we're only meddling 3 spots. Spot 4, 5, and 6 doesn't count. Doesn't matter. Okay. For when I'm running a race with 6 people and 3 spots, how many people have the option of getting number 1? 3. 4. How many people are in the race? 6. 6 people. So 6 people have the chance of getting first place. How many people have the chance of getting second? 5. How many have the chance of getting 4? After that, it doesn't matter because I said I'm only meddling 3 spots. So 6 times 5 is 30 times 4. Times 4, 120. So with these 6 people, there's 120 ways that they can meddle 1, 2, 3. That's a permutation. It's figuring out how many different ways things can happen. So that's what we're talking about today. Another thing I have to talk to you about is the definition of a factorial. The definition of factorial.
Oh, is this the digits?
Factorial. It's used to write an answer. So product is the answer of a multiplication problem. When the factors are consecutive. Okay. The symbol is an exclamation point. Yeah, that's the symbol, isn't that cool? All right, so here's the thing about a factorial. You can only use it when you go all the way to 1. Okay, so here's an example. Remember the first 4 that I had running their race?
Yes.
Okay, when we talked about, I'm gonna line them up 4 different ways. 4 times 3 times 2 times 1. I went all the way from 4 to 1. That's when you can use factorial. Remember then the last one I did when I had 6 and they only met 3 spots, did I go all the way to 1? I went 6 times 5 times 4, right? I did not go to 1. That's when you cannot use a factorial. Now let me show you how it works. Okay, if you were going to put 4 times 3 times 2 times 1 in your calculator, do that. You do 4 times 3 times 2 times 1 in your calculator. You get 24. Well, there's an easier way, and that's that factorial, instead of putting all that line in your calculator. Now, if you have a calculator that looks like mine, I'm going to show you how to find it. I know I've done the others also. So just listen. If you have one like mine, on there is a PRB button. It's kitty corner from the second. Okay? Some of you will have this instead. Look for this. Some of you have this instead, like on a button somewhere. Sometimes you have to press second. And then that, so look for that on there as well.
I have times -1, I have, times 2.
Yeah, that's times 2.
Of a PRB, please.
It's in yellow. So when you have to use it, you just shift and then this one right here. Okay. So you found yours? I don't know if yours has done it. I'm sure it does. But it's just. I'm not sure.
It says here.
That's because you didn't use it correctly. I'll show you how to use it. Yours is right here. Exclamation mark. Oh. So when we use it, you'll use this. Everybody else find theirs? Find yours?
What do I do now?
I'll tell you what to do. Hold on. I just gotta show you what to do. Get it right.
Oh, do we select the explanation point?
See that right there? So when we use it, you'll shift and use that. Yep, we're gonna go over to it. You find yours, Matthew? Okay, so this is how it works. Yep. You're gonna go shift and then that's it. So I'll show you how to use it next. So this is how it's gonna work. Right here. You shift and then that. Okay. All right. So let's just do this one and with the factorial. So on your calculator, push the number 4. Push the number 4. Then go find your exclamation point. Some of you have to do shift and then another key. Some of you have to push the probability button, go over to the exclamation point and push enter. And then if you push enter again, it's going to give you 24. So let's find the factorial of 6 now, which means you're going to do 6 times 5 times 4 times 3 times 2 times 1. So put in your 6. Find your factorial. Enter, 3, 7, 20. So all you do is put in your 6, what it starts at, your factorial. What it means, what the calculator is doing, when you put in 6 in your exclamation point, it's doing 6 times 5 times 4 times 3 times 2 times 1. That's what it's doing. You don't have to do it for it. Okay, it automatically knows that's what it's doing. But you can only use it if you're going all the way 1.
What if you don't want to use it? What if you want to do it that way?
That's fine, you can do that. This is just a shortcut. And you know, there's so many things that your calculator can do. This is one of them. I mean, I just wanted to show you how it works. So let's say how many are in here? 9? 1, 2, 3, 4, 5, 6, 7, 8. Let's do 9 factorial, because this will tell me how many ways that I can arrange in the class. So what do we do? 9 factorial. Oh wow. That's how many different ways that I can arrange in this classroom. So this is even crazier. Try my other class. My other class is 19. It's going to be like 1.216451004 times 10 to the 17th power. Does it say times 10 to the 17th power line in it? Doesn't say anything. It means that if you move your decimal 17 times to the right, that would be the number. It's probably over like
I can test that.
That's okay, 19 people. But that means that this is, okay, so that means if I were to say you and this person move up, that's one. You and the next person, that's two.
Oh.
So imagine like doing that for everybody and then shifting you all, I mean, it would take forever. That's why we have computers to cover. That's why we have that one. And we have that. All right, so let's show you how this is going to fit, okay? Here's some examples. This is what we're going to start with. So if you need some examples, make sure you get them in. Now, you will not always need to use your factorial. You only need to use that factorial when you're going to find every single place all the way to 1. You don't always need it. So if you listen and read, it'll kind of tell you what you need. So it says your phone has 5 sums on it. You don't want to listen to any of them twice. Find the number of orders the songs can be played. Well, okay, if I have 5 songs, first place, I have 5 possibilities. 4 would be my second, 3 third, 2 1. Is this the time you can use a factorial? Yeah, this is the time you can use factorial. So 120 ways that those songs can be played on your phone in different orders. 120. Okay, here's another one. I don't want to do this one. I'm actually going to change this. Let's do 7 chips and numbers 1 through 7. So if I have 7 chips, the numbers 1 through 7, I want to know how many different ways that I can pull these out of a hat if I pull all 7 out all the time. So can I use factorial on this one? Yep. Yep. 7 factorial. 5,040.
Overflow.
Okay, now, here's one that's a little different. This says 8 people run in a race. Only the first 3 get medals. How many different ways can medals be given out? Can I use factorial here? No, because I'm looking at the first 3 spots. For my first spot, how many possibilities are there?
8, 7, 6.
Multiply them together. And that's how many different ways medals can be given out just for first, second, and third.
336.
336. Okay. How are we doing? So far, so good? Yeah, if you read it and you think about it, it will be easy. All right, here's another example. No, there's a little more to this. There's another example here. So think about this, because you're probably going to have one of these as your homework. It says the members of student council are shown. Jake, Betty, Beth, Kristen, Tina. Then it says, what's the probability that Jake is selected president and Tina is selected vice president? The first thing I have to do is I have to figure out how many possibilities I have here that could be president and vice president. So how many people could be president? 5. How many can be vice president? No. 4, because if somebody's president, he's out for vice president, right? So how many possibilities are there? 20. Now, what's the probability that I'm going to have Jake as the president and Tina as vice? 1. It only would happen 1 time. That's the probability. The hardest part of this is figuring this number out. That's the hardest part.
That's easy.
But some people look at it and say, okay, now what do I do? Think about it. Seriously, make stuff like this. Make spots if you need to make spots for yourself. So help you figure out what you need to do. Okay, last thing I need to talk about is this. Sometimes permutations will show up looking like this. You will need this in your notebook because you will forget what this is when you get to your test or your semester test. This P can mean permutation or probability. Okay? Many times permutations will show up in a story problem like I just showed you, or they'll show up just in this format. That's it. And you have to know what to do with these numbers. A lot of you, if you just looked at this, you would take 10 times 3.
No.
Some of you, if you just saw it on the paper, oh, 10 times 3, it's got it right. But these actually mean something. So if I put it in terms of everyday life, what we've been talking about, this means how many people are running your race. 10 people. This means how many ways you're medaling.
3.
Okay? This is what it would look like. Solve it. It's going to be 720. This is what I want to see for all work today. I don't care if you need to calculate it. Again, I want to see what it looks like, what you're doing. Matthew.
Can you just put the exclamation?
If you use it, You can put that, I'm fine with it, because I know what that means, but you can't use that for this. You cannot use that.
So when it says like, it doesn't, like, you can use every single number or something like that.
Yep, then you can do this, definitely. Okay, let's
It's
practice.
like only the top 3.
Correct. Mason.
So what are you gonna get, 10 times back to you?
Okay, so this, if I put it in terms we've been talking about today, that first number always means how many people are running your race. That second number means how many they're medaling. So they're only what first, second, and third for this race. So like we start with 10, and you go 3 spaces. Then you multiply them together, and that's your answer.
Oh, so just go.
Yeah, just,
down like
yeah.
numbers.
Yeah. Correct, correct. So if I go to this one, let's look at this one. So what does this mean?
8 times 7 times.
8 times 7 times 6, it's 8 people running your race, you're medaling 3 spots, this is what it would look like. And then you solve, okay? Like this one here. What about, let's talk about this one. What would this one look like?
4, 3, 2, 1.
Yeah, this is one you could use factorial for. So if you have the same number, that's when you can use factorial for, because that's telling you that 4 people are running a race, I am medaling 4 spots. So if you have the same numbers, that's when you can use factorial for. What about this one? What does this one look like? 12 times 11. This one, 10 times 9 times 8 times 7 times 6, and you times 5 then. 10, 9, 8, 7, 6. Is that right? 10, 9, 8, 7. Oh, this is 6.
Well, you're on the
Right here, this would be this one. This one would be this. That would be this one. 10 people running a race, medaling 5 spots. Yep. The last thing I need to talk about is when you're talking about numbers. How many digits are from 0 to 9?
9, 8.
10. 0 to 9 are 10 digits. Because this is going to show up again today.
Normally you don't count 0.
But today we are. That's why I said digits from 0 to 9.
Since like preschool, they told us not to count it.
Today you're counting it. Because it can be known as a digit in your number, right?
No,
So if you have a 3-digit number, how many possibilities are there? Well, what's going to go in this spot? 10. That's how many possibilities I have for a 3-digit code. Yeah, that's a lot. This is a 3-digit code. So seriously, put this in your head because you're going to see this a lot. You're going to see that a lot. All right, what questions do you have for me? That's all I have for you. That's it. That's it. Matthew.
Is there any we aren't supposed to do at home?
No, all of them up there. All of them up there. I would have figured that out a long time ago.
Well, like yesterday, you put up